Hello, welcome to another video of CS106A, assignment 5, Yahtzee. And here, we're going to work on part 3, and this is going to be for the check special category, and if we have enough time, I'll try to wrap it up with the total of results in the calculate winner. Basically, as you can see, it's all red because we haven't made the method for it yet, and so down here, I'm going to go ahead and stick that in and create the method. So how do I create this method? Well, if we're going to be checking to see if it's going to fit a certain condition, then what we're going to do is make it into a boolean, and that's how we stated it here. It's like if something, if it's true, and that's why we made it a boolean. So we got to put boolean. It's going to return a boolean and basically take in the parameter of which category we're talking about. Okay. Now here's the trick. The trick is there's two types. Well, there's two constructions for the array list. One is the one you saw where the set dimensions are set. One is where you can create a wrapper of the integer in a object world like array list. And so what that means is a different construction for array list. And in this version of the array list, you can add, remove, manipulate these objects. So first, what we're going to do is create an array list for each and every side of the dice. 1, 2, 3, 4, 5, 6. So integer 1, and then to call it, we call it the new array list of integers. Okay, and then you're going to do the same thing except for 2's. So to kind of speed this up a little bit, that would be 2, 3, 4, 5, 6. So 1 for 2, 1 for 3, 1 for 4, 1 for 5, and 1 for 6. And here, what we're going to do is we're going to read our array list of dice roll, and we're going to add an element to each of these numbers, depending on whether it's in the 1, 2, 3, 4, 5, 6 category. So 4, and you've probably seen this so many times, int dice is equal to 0. Dice is less than the number of dices. That's going to be that. Dice plus plus. Okay. Now what we're going to do is if we see the statement of when if that dice roll of that index dice happens to be equal to the value of 1, we're going to add an element of 1 to the 1 array list. And that's how you do it like this. Okay. Could be any number, doesn't really matter. I chose 1, could be 0, 2, 3, 4, 5, but I'm adding an integer. It's being wrapped. You can't put a primitive type into an actual array capital L list because they're objects. And so the wrapper class of the integer allows them to be added to the array list as these numbers. Okay, so I put 1, could be 10, could be 5, doesn't really matter. I added the integer of 1 to the first box. In the boxes, they're not set dimensions. This is the nice thing about the array list. You can increase and decrease the size of this array list, so you'll see how that actually gets used later on. If it's not 1, else if the dice roll happens to be 2, so it's like this, 2, then we want to be able to add to the 2 array list. Okay, and again we can copy and paste 3, 4, 5, 6. So if not the 2 but the 3, if not the 3 but the 4, if not the 4 then the 5, not the 5. So this part's pretty easy. 5 and 6. Okay, so the way it works is that if my rolled dice roll is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, then it's going to add one element to 1, to 2, to 3, to 4, to 5. And then we can use that to be able to determine different configurations of a straight, 4 of kind, 3 of kind, etc., etc., etc. So now that we've created this, okay, the next thing to do is now to write the algorithm that will read in these different categories. So if let's start with 3 of a kind. If the category is equal to a 3 of a kind, okay, then what we want to do is to write an algorithm that can check that. So how do you do that? Well, first, if our one size, the size of our one array list, happens to be greater than or equal to 3, because you don't know if it could be a 4 of a kind or a 3 of a kind, but it happens to be greater than or equal to 3, then we can say that is a 3 of a kind. Or if our 2, I don't know why I put ones, if our 2 happens to be the size that's also greater than or equal to 3, same thing, that's a 3 of a kind. Copy this over. If our 4 3s, 4s, 5s, and 6s, okay, hit enter there so it wraps around. Okay, so if our one's array list is greater than or equal to 3, 3 of a kind, same with 2, same with 3. See what I'm doing here? This reads the different configurations. These horizontal lines means OR. Okay. If any of these things happen, then what we're going to do is we're going to return true. Yes, this is the right configuration. Return true. Okay. Else if our configuration is a 4 of a kind, okay, so then what we're looking for is if it's a 4 of a kind, then it's going to read the same thing but with 4s. 4, 4, 4, 4, 4, 4. And then what we're going to do is still return true for that one as well. Now, what if it's a different configuration, like a full house? Okay, so like a full house, like that. What do we do now? Well, first, we check if there's a 3 of a kind. So here, copy and paste the conditional statement. If it's equal to a 3 of a kind, and it's got to be equal to, can't be a bigger number than that, then what we're going to do is we're going to have it read one more if statement. Okay, so if that's true, if one of them is a 3 of a kind, the second one should be a 2 of a kind, or a pair. So the second part should be a pair. Notice how I'm doing a lot of copy and pasting here. Totally legit. So if it was a 3 of a kind, check to see if the other one's a 2 of a pair. If that's true, then what are we going to do? We're going to return true. So here, if that's true, then we're going to return true. Okay? So that's for the full house. A little lengthier, but hopefully you see what just happened there. Check for the 3 of kind, check for the pair. Okay, what happens if we want to check for a straight, a small straight? So 1, 2, 3, 4. Okay, that would be a small straight. So to do that, we type else if category is equal to the small straight. Okay, if that's true, then what are we looking for? Well, then we want to see if it has, if it's equal to 1, 2, 3, 4, or 2, 3, 4, 5, or 3, 4, 5, 6. So let's type that out. So if one size is equal to 1, and the 2 size is equal to 1, and the 3 size is equal to 1, and 4 size is equal to 1, then what we're going to do is return true. Okay. Else if, what about the other case? What if it was 2, 3, 4, 5? So instead of having this here, what if it was 2, 3, 4, and 5? Then it would still return true. What if it was 3, 4, 5, 6? Then it would still return true. Okay? And that's how you do it. So that's the small straight. Let's go ahead and get into the large straight. So else if the category is equal to the large straight, and here, instead of 1, 2, 3, 4, we're going to have 1, 2, 3, 4, and 5, right? So let's put that in. 1, 2, 3, 4, and 5 size is equal to 1. Then return true. Okay? And then we want to check the other one. Else if it's now 2, 3, 4, 5, 6. 2, 3, 4, 5, and 6 size. And we're going to have it return true as well. Okay? Now, what happens if we have a Yahtzee? That's a 5 of a kind. So then here, we're going to put else if our category is equal to a Yahtzee. Then here, we're going to check if there is a 5 of a kind. And the easiest way to do that is by taking one of our previous ones. Let's take this guy right here. Okay? So if it's a Yahtzee, then we're going to check if it's a 5 of a kind. If that's true, then it's a Yahtzee. Replace, 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 replace. Love that copy and paste. Okay, so that is for a Yahtzee. What if it was a chance? Okay, now if that was a chance, it's pretty easy. That's just return true because anything would work. Okay, and that is how you would create the check special category method. Now, the one thing that you need to remember is if none of these work, then what do you need to automatically do? Return false. And when you return false, it would say that it's not the special case. And when it's not the special case, it would go with the else statement, which is put a score of 0. Okay. Looking at the time, we have plenty of time. I'm going to go ahead and finish up the rest of the program. So let's take a look at the next one that we got to work on, which is private total up results. Okay. In private total up results, what we need to do is add up the top column, the top half, and the bottom half. So let's get to it. So here, the top half, 1 through 6, adds up to the upper score, adds the bonus if you are over 63, and the bottom half is added with a lower score, and the total is given at the bottom. So to do this one, let's first have a running count. So we'll create a int called result, right? And then what we're going to do is we're going to go to each player. So that's going to be a for loop for each player. Int player, oops, and then equals to 0. Player is less than. And what did I do equal to 0? I did equal to 0 because basically when you look at the scorecard, it's going to be an index of 0. So I'm going to use this reference based off the scorecard. So player less than the number of players, and player plus plus, so that I can count those players. Next, what I want to do is to also calculate the total for each category. So for int category, that's equal to 0, again because of the index. Category is less than the number of categories, but since we're only doing the top half, that would be our 6's. Category plus plus, and we're going to add each one. So how we're going to add this? Well, we take our result, we're going to plus add it the values from our scorecard into our results. And because the category is already indexed at 0, we don't have to manipulate that, so it's totally fine. Okay, scorecard has a small c because it's one word. Next, once you add up the total top half, we want to put that into the upper score. So let's first stick it on our scorecard. So stick it in our scorecard. Remember, we're indexing based off the two-dimensional array list. So that's going to have the reference starting from 0. So we got to subtract 1. And then next, what we need to do is to also take into account the player, which you don't need to change because player is already at index of 0. And then we're going to put our result into that slot. Okay. And of course, once you do that, we want to display this solution onto our scorecard on the graphics, and that's going to be the upper score category with the player, which in this case, because it was referenced based on our index of 0, we have to add 1, and our score is really just going to be the result that we were holding on to, keeping track of. Now we got to check if there is a bonus. So if you happen to get over to a score of 63, we'll add a bonus to your score, so scorecard. We're going to check to see if our upper score is going to be greater than 63. So take this. Player is greater than 63. And if that's true, that would mean that our scorecard upper bonus should now be, if that's true, we're going to fill in that spot and say that that spot in our two-dimensional array will have a value of 35 if it's over 63. If it's not, then it's going to be 0. So our scorecard will be a value of 0. Okay. Now remember, again, once you put it into the scorecard, make sure you update it onto your graphical interface. So it would be the this is a little bit off. What I did was, if you check the scorecard is over 63, we're adding 35 not to the upper score, but rather to the upper bonus spot. This spot right here. We're not replacing that number, we're replacing the bottom number. That would have been a mistake. So, upper bonus, there we go, fixed it. So that bonus spot is going to be a value of 35. If you're not over 63, it will be a value of 0, like that. Okay, which you still need to display, and not under upper score, under your upper bonus. Okay, alright, everything looks good so far. Now, once you do that, you want to go ahead and do the lower half. Now, before I begin, I just caught something. The results here, okay, it's not the result that we're adding. We're adding 35 there, and we're adding 0 there. Because 35 for the bonus, that's the score that we're putting in, and 0 for the no bonus if you don't reach that. So make sure you do that too. Next, what you want to do is you want to go ahead and calculate the lower half. So to calculate the lower half, make sure we change our value of result back to 0. Okay, because we're going to use it again to calculate our lower half. So to calculate the lower half, we can go for int category. We used category because the previous variable category has been used up and it deleted itself. So we can say category again, and category is less than chance because we got to add the lower half. And I made a little boo-boo because we're not starting from 0, rather we're starting from here. And here would be a value of 8. So 8, 9, 10, 11, 12, 13, 14, 15. And why did I count 8? well, 8 through 14. The reason why I call it 8 is because again, it's not going to be based off the graphical interface. You got to keep remembering it's a scorecard from the two-dimensional array, which has an index of 0. So here, it's really going to be 8 instead of 9, and that's where you're going to start your counting of your bottom score. So you're going to take our result plus equals our scorecard, and that would be our our category, because it's based off our two-dimensional array and the player index. Okay, and it's going to add all those up. Now once you add it, we want to put it now into our lower score category. So lower score category. Remember, it's different on a two-dimensional array, so you got to subtract 1, and then player doesn't change because that's index of 0 still. Result, and that plugs in the new value for the lower half, and then you need to display that like we did before with the other ones. So display and update our score, and so the category will be our lower score, which is the graphical real answer, not the two-dimensional array, and then our player is correct, but make sure you add that 1 to adjust for the graphical interface, and our score will be our result. Okay. So that's how you add the lower half. Alright, now finally we need to get our total score. So again, take our scorecard, and we're going to go ahead and put our total into the bottom, and this is for the two-dimensional array, so that's why we subtracted by 1. So total player, and then will be the values of the upper score, upper bonus, and lower score. So we're going to add those three together, and that will equal our total. So scorecard of our upper. Okay, let's type that out. So score card of our upper score minus 1 with our same player index plus the scorecard of our upper bonus plus don't know why I did that with all those dots. Interesting. Okay, let's fix that again. Delete that. Okay, plus our score of well, that kind of bites, of our lower score. Okay. So we have the upper score, the upper bonus, the lower score. That will equal our total. And once we have that done, we want to display that solution as well. So display dot our our update score card, and the category will be under total. Our player will be player plus 1, because this is based. You have to keep reminding yourself: is it the two-dimensional array that you're referring to? Is it the graphical interface? So keep talking to yourself so you don't make that mistake. Keeping quiet sometimes can lead to that mistake. You might just assume that it's one way over another, and the score will be the total that we just calculated right there. Okay, and then once you do it for the first player and do all that updating stuff, make sure you reinitialize the result to 0, because here it doesn't reinitialize because it's outside that loop. So initialize the result for 0 down there, and then it will do it for the next player, and the next player, and the next player, up to 4 players. Okay, the last part is calculating the winner. So let's finish that really fast. So private void calculate winner. Okay, so to do this one, because it's a void, it's very easy. We want to have an index of the winner, which is the player, and we want to have an index of the score of that winner. Okay, going back all the way to assignment number 2. So for int player, we're going to see if the player has a higher score than the other player. So check for the number of players, and then it's going to count up. And what's going to happen is if our scorecard total, so that we're going to compare totals values, total in our player is greater than our score, then let's replace it. So our score is going to be equal to whatever that value is, with the winner equal to whoever that player is. Okay. Nice thing about this loop is that since it's 0, any score over 0 will be, the highest score. And then if there's another score that's over that, then that would replace the first score. So this is the algorithm for comparing scores. Okay, it's an adjacent type of algorithm, not the best, but because it's only 4 players, not a big deal. And then once you're done, of course, we got to display this guy. So display and print the message for congratulations. It's right here. So congratulations to whoever it is. So who is it? I guess we'll have to access our player names with the winner, and then comma you're the winner with a total score of whatever the score is. Okay, and that should be that. Now I don't like how long it is, so hit enter. We'll have it wrap around, and then you're done. So now all you have to do is run this program. Now all you have to do is run this program. See, test it out. Let's say maximum 4. Okay, Kai, Sam, Jenny, and Liza. And there you have it. Roll again, and then select the category as 5s. Oh, I didn't have any 5s there, did I? Whoops. Roll again. 3s. Roll again. 1, 2, 3. Let's see if I can actually get something this time. 4. Small straight. So 1, 2, 3, 4. Let's go small straight. 1, 2, 3, 4. I think I did that right. Hold on. Let's roll again. Okay, so full house. There we go. Looks right so far. 1, 2, 3. Let's get 4. No 4, but we have 3, so 3s. 1, 2, 3, 4. Let's get a 5. Okay, this is a small straight, right? 1, 2, 3, 4. So small straight. Well, it's a good thing you test the algorithm. Let's check to see if the other one works. So 1, 2, 3. This is nothing. This is 3s again. Let's do. Oh, I clicked on 2s. 1, 2. No. 2, 3. Okay, so that's nothing. So let's put that under 6s. Let's check the chance. Chance works. I don't think a Yahtzee would be possible. It's going to be kind of hard to kind of get a Yahtzee. 2, 3, 4. Okay, I need a 2. So 2. Yes! Alright, nice. Alright, large straight. There we go. So it looks like they all work. Really, they pretty much all work. This is a 3 of a kind. Let's put that there. Whoops. Ah, man. Clicking on the wrong ones now, huh? Okay, let's get that. Shoot. 1, 2, 3, 4. Small straight. Oh yeah, roll again. Small straight. Okay, so the one issue is the small straight. So to fix that one, you go back, troubleshoot it, see what the issue is, and then see if you can fix that. 1, 2, 3, 4. That's right. 2, 3, 4, 5. That's right. 3, 4, 5, 6. That's right as well. So then let's look at the calculation. The calculation, if you get a small straight, if it's the category, you'll get a 30. Else, you get a 0. Hi, I just realized what the problem was. Okay, so the category for small straight, I put equal equals. Really, it can have 2 and 1, so we want to incorporate the fact that possibly there is more than 1 in one element, or one array list. So if that was the case, that shouldn't bother it at all. So changing that to greater than equal to 1 should solve that problem right there. So greater than equal to 1, greater than equal to 1. So one of them can have a value that's bigger than 1 in an element, and that should be the reason. So when I run this program again, you would find out that that solution is fixed. So let's quickly run it. Okay, so roll the dice, and 2, 3, 4, 5, 6. Okay, perfect. So if I go here, go small straight, boom. So again, hope you like this video. Please like and subscribe. And if you have any questions about your own algorithm or with mine, go ahead and please write a comment, and I will try to get back to it and see if I can help you out with that. All right, thank you very much. Bye.